Hello everyone, welcome back to my another channel with another some interesting topics. So if you are from ECE branch or if you are ECE students, then this video is for you. If you are not, then fine, you can just like and subscribe, then you can close this video. So let's dive into this topic. So today our topic is about block diagram reduction, which comes under the part of control system. Before going into this topic, I just want to discuss about what is control system and why we are discussing about block diagram and block diagram reduction rules and why we need that. So control system, like for system you can take example of fan, TV, or any mechanical system which is working on some equipments like laptop, fan, mobile, etc. And so this system works on some basic principles, and to show or to represent that how system is working, we need a certain kind of diagrams which helps to understand or visualize and analyze that how the system is working. So for that we have a block diagram. For example, if we take an example of fan, like if I draw the structure of fan in the terms of block diagram, then I can easily visualize that how the fan is working. And to control the fan, we have a regulator. And basis on this, I can know how to structurize the fan. In control system, mainly we have a two types of loop. One is open loop and second one is closed loop. In open loop, the output is directly dependent on the input, but not in the case of closed loop, where you can see that the closed loop depended majorly on the environmental condition, where the it sets the input according to the environmental condition. For example, like in hot weather or in the winter season, the fan gets set its speed according to the seasons, and that's come under the closed loop condition. So we have discussed the some basics about the control system. Let's dive into the block diagram reduction. In block diagram reduction, we have certain rules. We know the rules are meant to be broken, but not in the case of this. So let's discuss about the rules. The first rule is check for the block connected in series and simplify. And second rule is check for the blocks connected in parallel and simplify. Checks for the block connected in feedback loop and simplify. If there is a difficulty with takeoff point while simplifying, shift it towards right. So you have to remember all these points. If I if I start discussing this point one by one, then I know that the video will get it stretched to 20 minutes of video. So rule number 5, if there is a difficulty, okay, we will discuss one by one. If there is a difficulty with summing points, we will shift towards left. We we are discussing this rule to make it easier to simplify or to solve this diagram. For example, consider this block diagram as shown in the figure. So let's simplify by using some rules. The step 1, use rule number 1 for block G1 and G2. Then use rule number 2 for G3 and G4. Then modified block diagram is shown in following figure. I don't know how to say it, but I can't show it practically here. So for okay, to know the steps, you need to remember this rule. So for according to the rule 1, I need to just combine this box. According to the rule number 2, I know this you know that these are in the parallel. So for parallel we have different rules, and for series we have different rules. So if we simplify it, we will get this condition where the series get multiplied and the parallel get added or subtracted according to the symbol which has given in the figure. Then we will use some rules here to simplify the block into a simpler form. So use rule number 3 for block G1 and G2 and H1, and you use rule number 4 for shifting for shifting takeoff point after the block G3. We have shifted this point to the right hand side to simplify this problem, where the G3 plus G4 get multiplied with the G5, which will give the more simpler form. And as we shift this point to here, the H2 get divided by the G5 because it's passing the G5. That's why it get divided by the G5. If it's moving toward the left side, then we can directly multiply it by the G3 plus G4. Then got into this simpler form. Now it's in series form. So that's why we will multiply these both boxes. Then we will apply some rules, and we use rule number 3 for block connected in feedback loop. The modified block diagram is shown in the following figure. This is a simplified block diagram. And by this, we can generally raise a formula called, I think what we call, I don't remember the formula or the exact term that we call this function. So note, follow this step in order to calculate the transfer function of the minor diagram having a multiple inputs. So and while solving this, we get small minor block which we need to solve by using formula called, I think, C of S by R of S. We need to divide the output and input to get this form, and we can easily get the easiest form as we can see on the screen. To find the transfer function of the block diagram by considering one input at a time and make the remaining input as 0. Repeat step 1 for remaining inputs and get the overall transfer function by adding all those transfer functions. The block diagram reduction process takes more time for complicated system because we have to draw the block diagram after each step. So it is time-taking process. So to overcome this drawback, use signal flow graphs. So we will discuss this topic after this topic, but we don't have that much of time, so we will discuss this topic in another video. So signal flow graph make it easier as compared to this block diagram. So that's all for today, guys. Thank you for watching till here. Make sure you hit like and subscribe button. Thank you for watching till here.